If you follow the weather, you must be aware that weather has drastically changed in previous years, and climate change is the primary dispute between weather experts. Many believe that this is due to climate change, but experts disagree with this, as they think there is something else that causes the change in weather pattern, and that this change is not affected by climate change at all. According to the experts, let's look at what causes a change in the weather pattern. Australia is one of the main countries affected by these weather changes in recent years. The country is facing major flooding and cool summers due to the La Niña winds that have hit the country's east coast in recent years. Before we move on, do you know what La Niña winds are? La Niña and El Niño winds. La Niña is a climate phenomenon that initiates in the Pacific Ocean and can have fluctuating weather effects. When the ocean's surface interacts with the winds, it either warms or cools. The colder phase of the temperature change is known as La Niña, while the warmer phase is known as El Niño. These phases are together called an ENSO cycle, El Niño Southern Oscillation. These phenomena can never occur at the same time. These weather patterns result from inconsistent ocean temperatures that lead to extreme weather conditions, such as heavy rainfall or severe droughts in different parts of the world. When the cool water builds up in the Pacific Ocean, La Niña occurs, causing the atmosphere to cool. The air became drier and cooler due to less evaporation. As the air didn't develop into storms, it resulted in less rainfall and brought droughts. On the contrary, when warm water builds up along the Pacific Ocean, El Niño occurs. This results in the rising of the air as well as increased moisture in the air. More moisture leads to heavy rainfalls and increased coastal flooding. Although the tropical Pacific is the most affected by ENSO, it can also impact other regions such as southern and eastern Africa, Australia, Antarctica, etc. Among all these regions, Australia has faced the La Niña events and has seen 3 La Niña events. These La Niña events are uncommon as the events alternately change annually between both El Niño and La Niña. The country has been experiencing wet and cold conditions in recent years due to the consecutive La Niña winds that carry colder winds from the eastern Pacific and blow towards parts of eastern Australia. On the other hand, Southwest America is facing extreme drought and dry weather due to the warm winds caused by the El Niño events. Here is some good news for the East Australian region. It has been predicted that this third wave of La Niña events would be weaker and shorter than the first 2 events, but the country has faced severe and intense rainfall in previous spells, and the country has hardly recovered from the last flooding. The soil even has not dried up because of the heavy rain, and the areas such as Queensland and South Wales are still recovering from it. Let's have a look at if greenhouse gases have any impact on these ENSO events. One of the research in Australia concluded that the increase in surface temperatures due to greenhouse gases would further strengthen the frequency of ENSO effects in most parts of the country. The experts have concluded that the frequency of ENSO events has increased drastically since the 1950s. But that does not mean the entire increase in these events is due to greenhouse gases. It might be due to the rise in temperature levels across the Central Pacific. Is it possible to go back in time and see what climates were like back then? Definitely not. Thousands of years back then, scientists used to track the occurrence of these ENSO events using the instrumental record and paleoclimatic proxy records. It is the sources of data that tell us about past climates. Imprints, also known as proxies, are used by scientists created during past climates to interpret the weather. Ice cores, tree rings, lakes, seas, and sediment deposits serve as climate proxies observed by the scientists that indicate different patterns of these fluctuating ENSO events recorded in 11,000 years. And similar fluctuations in the patterns of these ENSO events are predicted for the future. However, scientists do not indicate any consent regarding the change in sea surface temperatures concerning greenhouse gases over the next few years or even the next few centuries. But one thing is for sure, the rainfall variability over the eastern central tropical Pacific will increase considerably over the next few years. Do you know what other factors beside these greenhouse gas emissions cause these intense flooding and droughts? Experts have concluded that there are more climatic forces at work that regulate the intensity of both drought and rainfall. These include the southern annular mode and the Indian Ocean Dipole. Indian Ocean Dipole. Do you know what it is? It's a climate phenomenon that refers to the difference in sea surface temperatures in opposite parts of the Indian Ocean. It is the cycle of global climate and is very much like El Niño in the Pacific Ocean, known as Indian Niño. It has different phases as the temperature in the eastern part of the ocean fluctuates between warm and cold than the western part. An Indian Ocean dipole has three phases: the positive, negative, and neutral. Greater sea surface temperatures and more significant precipitation is seen in western parts of the Indian Ocean in a positive phase that causes droughts in Indonesia and Australia. On the other hand, the negative phase has opposite conditions, with greater temperature and precipitation in the eastern part of the Indian Ocean. An Indian Ocean dipole caused heavy downpours that resulted in flooding in East Africa, while causing extremely dry and hot weather conditions in Australia that led to bushfires a few years back. As per the experts, it has been predicted that the dipole's effects will likely become more common in the future due to the increase in greenhouse gas emissions. Let's go through a little bit about the southern annular mode. Southern annular mode. The north-south movement of the strong westerly winds blowing in the southern hemisphere. It's a climate factor that impacts rainfall and temperature in Australia. Similar to the Indian Ocean dipole, the southern annular mode also has three phases: the positive, negative, and neutral, with each phase lasting for around 1 or 2 weeks. In a positive phase, the wind belt moves towards Antarctica, bringing more rainfall in southeastern Australia in winter, while decreasing rain in the southwest. This phase occurs more frequently with La Niña events. On the contrary, the negative phase involves the wind belt that moves towards the equator, decreasing rainfall in southeast Australia in summer, while raising the chances of heat waves in spring. Unlike the positive phase, this phase occurs more frequently with El Niño events. The combination of all these climatic factors is not bad for Australia altogether. With 2 La Niña events in the past, cooler temperatures and regular rainfall will significantly reduce the effects of worse droughts in Australia in recent years, and the country will be less likely to face droughts and bushfires in the near future. Although the cooler winds that La Niña brings along will undoubtedly reduce the temperature of the Pacific Ocean, it is not long-lasting, as the continuous greenhouse gas emissions will raise the temperature back again. Soon the La Niña event will be replaced with El Niño events. While keeping the past La Niña events in mind, residents of Australia should mentally prepare for another season of cold climate and heavy downpours. As the effects of ENSO events are directly related to climate change, the main concern is how these effects will reflect future changes. The growth of ice in Antarctica has also been impacted by changing patterns of wind and ice. Climate experts have observed the increase of ice sheets in the eastern Antarctic Peninsula since the 21st century by using satellite imagery to understand the ice conditions in Antarctica. The study involves using the 1,400-kilometre-long ice peninsula and concluded the 85% increase in the ice shelf around Antarctica. The experts also excurred to the continent to observe the growing ice sheets that have increased significantly since the 1960s. However, it is still unclear, as some experts indicate there will be ice loss to the polar ice caps, while others believe there would be a significant ice gain. As different models show different results of the ENSO events, the future predictability of weather changes is not entirely accurate. It is imperative to say how climate change might unfold over the coming centuries. What are your predictions for future climate conditions? Let us know in the comments below. We will be back with more exciting videos soon. Thanks for watching.